Hello, my name is Tine Lekeu and today I will present you a screening system in E. coli that we have developed with the aim to evaluate human homogentisate 1.2 dioxygenase enzyme variants in the context of rare disease alkaptonuria. Alkaptonuria is caused by the defect homogentisate 1.2 dioxygenase, an enzyme involved in the tyrosine degradation pathway. As a result, homogentisic acid will start to accumulate in body fluids and urine, will spontaneously oxidize to benzoquinone acetic acid and polymerize into ochronotic pigment, and this pigment preferentially binds to collagenous tissues, and on the long term, alkaptonuria results in an early onset and severe osteoarthropathy. Active AGD is organized as a hexamer, and this structure can be easily disrupted by mutations. So far, 251 AGD variants have been identified, from which a majority are missense variants. Missense variants, they might interfere with proper protein folding, protein instability, and most of the times they have some residual AGD activities. So far, there are only prediction models available that give information on a structural basis, but they do not give information on its residual enzyme activities. So therefore, there is a system required that it can evaluate these missense variants based upon their residual AGD activities. And on the other hand, if you are able to distinguish the missense variants from each other, it would be very interesting to evaluate the effect of novel treatment strategies, like for example, pharmacological chaperone therapy. Therefore, here we have developed an in vitro high-throughput screening system to evaluate missense variants based upon their ability to consume homogentisic acids. The principle behind the assay is as follows. On day 2, when bacteria are in their exponential growth phase, we add our inducer and our substrate, AGA, and we fill our plates with our expression cultures and incubate them further during 24 hours. After 24 hours, we measure the absorbance of piomelanin. A variant that has a lower residual AGD activity compared to wild type will have more unmetabolized homogentisic acid available to be auto-oxidized and polymerized into piomelanin, and this will result in a higher absorbance value. To evaluate the functionality of our assay, we created 8 different missense variants via site-directed mutagenesis followed by sequencing to verify if the correct mutation was introduced. On the left side, you see a picture of the 96 well plates, and you can visually distinguish the different missense variants from each other based upon their piomelanin formation. On the other hand, we have also calculated the residual AGD activities based upon the formula below. We can conclude that we have developed a robust in vitro screening system to evaluate residual enzyme activities. As a future perspective, this assay can be used to estimate the effect of pharmacological chaperone therapy. And moreover, the evaluation of an already available chemical compound library is very interesting in the field of drug repositioning, as these already approved drugs have been shown to be safe and therefore allow for a faster marketing authorization. Finally, I would like to thank you for listening, and if there are questions, please do not hesitate to contact me.